Imagine hiring an air taxi the same way you request a car today. No traffic jams, no waiting time, just a vertical lift to your destination. But what if that convenience comes with hidden dangers? Dear viewers, urban air mobility is no longer science fiction. Companies like Joby, Volocopter, Lilium, and Archer are already conducting flight tests. NASA estimates that by 2030, there could be thousands of small aircraft operating over major cities every single day. But before we get excited about commuting through the skies, we need to talk about safety. Because behind the futuristic dream lies a very real challenge: keeping people safe in an environment we've never flown in before. Urban air mobility is a highly promising option. That includes 1. Huge relief for ground traffic. 2. Emergency response that's faster. 3. Speedy medical deliveries, cargo, and passenger operations. 4. And completely new modes of urban transportation. But here's the problem. Our skies, especially over urban environments, are not empty. And unlike traditional aviation, UAM aircraft will operate low, dense, and frequent. NASA simulations predict that in some cities, we could see up to 400 operations per hour during peak demand. That's more traffic in the sky than many small airports handle today. And remember, many of these aircraft will be autonomous or remotely supervised, not manually piloted like traditional aircraft. Let's be realistic. Urban airspace is chaotic, having high-rise buildings, birds, weather turbulence, radio interference, existing helicopter routes, drones from commercial users. Now imagine dozens of UAM vehicles navigating through this environment at the same time. Here are 3 major risks that experts worry about. First is mid-air collisions. A NASA study showed that with high-density UAM traffic, the risk of loss of separation events could increase 5 to 10 times unless advanced collision avoidance AI is implemented. Today's TCAS systems are not designed for hundreds of aircraft flying at 300 to 500 feet. Second is component failures. Most UAM aircraft rely on high-energy lithium batteries, multiple electric rotors, complex flight computers. In traditional aviation, engine failure is rare, about 1 per 100,000 flight hours. But electric propulsion systems do not yet have equivalent long-term reliability data. The industry is promising multiple redundancy, but real-world operational reliability is still unknown. Third is cybersecurity. UAM aircraft will be cloud-connected and highly digital. That makes them vulnerable to GPS spoofing, data link interference, and remote hacking attempts. Resultantly, a hacked air taxi in a city center isn't just an incident, it's a potential disaster, affecting thousands of people on the ground. Next, we will talk about navigating the regulatory complications. Here's the question no one likes to answer. Who will be responsible when an air taxi crashes into a building? Right now, the regulatory environment is a patchwork, implying that ICAO sets international guidance, but not operational rules. Aviation regulatory organizations around the world all create their own certification paths. Cities control local airspace and landing zones. Manufacturers design the autonomous systems. Operators manage fleets. And telecom companies manage data networks. That's a lot of stakeholders, and not all of them agree to one another. Despite these risks, in this technological race, industry innovators are developing incredible solutions. First one is AI-based collision avoidance systems. In that domain, new systems are being integrated that include sensor fusion, LiDAR, radar, vision systems, and airspace awareness networks. It is claimed that these systems can predict and avoid conflicts faster than a human pilot ever could. Next is digital simulation. Companies are building massive virtual environments to simulate rotor failures, battery thermal runaway, urban wind tunnels, GPS jamming, and multi-aircraft traffic situations. It is envisioned that before any UAM aircraft ever carries a passenger, it may complete millions of simulated flight hours. Lastly, predictive maintenance. It will involve real-time monitoring of motor temperatures, vibration levels, battery health, and structural loads. These systems claim that AI can detect anomalies long before a human technician would. This is essential because UAM aircraft will only work if they can safely complete 20 to 30 flights per day. That is far more than a typical helicopter. Besides numerous operational challenges, urban air mobility also faces some ethical dilemmas. The main question being asked is that when a UAM aircraft faces a no-win situation or a potential crash, who will decide what happens? Should it protect the passengers first, or try to minimize ground casualties? Or should the aircraft be allowed to choose the least harmful crash site? It is recommended that these ethical dilemmas must be addressed before UAM operations start and not after the first accident. In view of the earlier discussion, it can be summarized that the future of urban air mobility requires collaboration between the regulators, manufacturers, air navigation service providers, emergency services, telecom networks, city planners, and lastly, the public. Please remember that safety is not a feature or a segment of urban air mobility. In fact, it is a complete ecosystem. We can conclude that urban air mobility has the potential to transform modern transportation, but only if we can rationally confront safety challenges. Therefore, the industry must focus on robust, unified regulations, transparent safety standards, massive-scale testing and simulation, secure and resilient communication networks, predictive maintenance, and real-time monitoring. And lastly, strong public engagement. Here, the real question to ask is, can we make urban air mobility safe, reliable, and trustworthy? Because the future of urban air mobility depends not on imagination, but on tangible responsibility. Lastly, as we stand at the edge of this new era, we must ask ourselves, are we ready for urban air mobility, or are we flying too close to the sun without a parachute? Thanks for watching.